In an era where data defines power, Japan is quietly reshaping the future of semiconductor technology.
The race to find materials beyond the limits of silicon has led scientists to nature's hardest gem, diamond. Inside tightly sealed cleanrooms like those of TSMC, diamond wafers are processed with atomic-level precision. Each wafer must achieve perfect atomic flatness before transistor fabrication can begin. Plasma chemical vapor deposition creates pure diamond structures mortness, where matter is arranged through light and energy.
These wafers will become the foundation for chips that operate where silicon fails, fluent, at temperatures beyond 300 degrees Celsius.
Is the most intricate stage, photolithography. Extreme ultraviolet light with a wavelength of 13.5 nanometer. Etcher in this.
UV light is focused through Zeiss optics from Germany, so precise that the error margin is only 0.1 nanometers, smaller than an atom.
Each lithography layer creates billions of circuits, thinner than strands of DNA, forming the heart of the processor. The automated system replaces photomasks and checks every detail with lasers. Even the tiniest deviation can destroy an entire chip. The wafer positioning system moves with microsecond precision, a perfect dance between light and matter.
Under the electron microscope, each transistor is only a few dozen nanometers wide.
After lithography, the wafer moves to the plasma etching chambers, where unwanted material is carved away with atomic precision.
Layer by layer, diamond becomes a living architecture of energy and logic.
Next, ion implantation and doping adjust the diamond's electrical properties, allowing transistors to switch billions of times per second.
Microscopic metal traces are then deposited to connect each transistor terminals, creating a network finer than a human hair. Each wafer undergoes hundreds of automated inspections for lasers, cameras, and AI algorithms verify perfection at every nanometer. After passing inspection, the wafer is diced into hundreds of chips, each a diamond brain capable of extraordinary resilience. Diamond processors redefine performance, operating flawlessly where silicon melts and fails. Their atomic lattice conducts heat faster than any known material types, allowing processors to run at extreme speeds without overheating. In data centers, diamond CPUs reduce cooling energy by half, reshaping the economics of cloud computing. In space, they survive cosmic radiation that destroys silicon, powering satellites and deep space probes with absolute reliability.
In electric vehicles, diamond processors manage power with unmatched precision, reducing energy loss and improving battery efficiency.
For quantum computing, diamond transistors become quantum gates, stable even at extreme temperatures and magnetic fields. In robotics and AI systems, they process complex data streams with near zero latency and no thermal throttling.
Each chip can operate for decades without degradation, a revolution in longevity and reliability.
From space exploration to AI research, diamond processors are not just faster, they endure.
Japan's diamond CPU marks a new era where intelligence is carved not in sand, but in crystal. The birth of diamond computing marks not just a new technology, but a new philosophy of intelligence. For Japan, precision is not only science, it is culture, a harmony between human hands and atomic order.
Each chip consumes less energy, produces less heat, and lasts longer, shaping a sustainable digital civilization.
Factories powered by renewable energy craft processors that no longer fight nature, but evolve with it.
With diamond computing, Japan aims to cut global data energy by 6%, but a revolution for both climate and technology.
The resistance variance is stable now. Check the Hall mobility at this angle. Data looks consistent with the simulation.
In global laboratories, engineers collaborate beyond borders, uniting physics, computation, and philosophy.
From Tokyo to Zurich, from satellites to quantum computers worry, the diamond chip becomes the heartbeat of a new world.
For the first time, computation itself becomes alive, learning, sensing, and adapting like a living organism.
In every atom aligned, in every photon measured, Japan finds not perfection, but balance.
Diamond computing is not a race of power. It is the return of harmony between intelligence and nature. Japan has shown that technology can be gentle, precise, and eternal, like the diamond itself. By 2050, Japan envisions processors that think, adapt, and evolve beyond. These diamond-based AI cores simulate the universe, decode biology, and design their own successors.
Quantum logic gates made from diamond qubits allow artificial minds to operate beyond human imagination.
Japan's diamond processors power not just machines, but the consciousness of a sustainable civilization.
Through light, carbon, and precision, Japan transforms computation into a living art form.
In every spark of data, a fragment of humanity endures Tili. Brilliant, eternal, diamond. From the heart of Japan, the age of diamond intelligence begins.
A decade after its invention, diamond computing has reshaped the foundations of global technology.
From supercomputers to smartphones, every device now breathes through crystalline carbon, fast, cool, and everlasting. Global emissions from data centers have fallen. Computation no longer burns the planet, but sustains it.
Across Africa and South America, diamond fabs powered by sunlight export clean computation to the world.
In Europe, AI governance evolves, guided by processors that value transparency as much as speed.
In the United States, quantum labs use diamond qubits to simulate ecosystems, predicting climate.
In Japan, computing has become an art, a dialogue between ethics, imagination, and precision.
The global economy no longer depends on extraction, but on refinement, light, and thought. Diamond technology bridges science and conscience, a quiet revolution driven not by power, but by precision. From the heart of Earth's carbon to the edge of human imagination, the story of diamond computing continues to unfold.
And as light accelerates, so does our understanding, Trav, guided by the brilliance born in Japan.
This is not the end of computing, Kang.